The wind howls across a sea of red sand and weathered rock, a place where the earth itself seems burned by time. You are in the heart of the Gobi Desert, 1923. The sun beats down on the now famous flaming cliffs, and every gust of wind carries the dust of ages. It is here, in this vast and unforgiving landscape, that a story is about to be written in stone. A story of a crime, a culprit, and a reputation that would be unfairly tarnished for nearly a century. Ever wonder what it truly felt like to be the first detective on the scene of a prehistoric mystery? We are so glad you've joined us on this journey. Before we dig in, let us know in the comments where you're watching from, and which prehistoric creature has captured your imagination the most. Now, let's journey back in time and uncover the story of a lost world. You are with the legendary expedition led by Roy Chapman Andrews. The team is unearthing a treasure trove of new species. Nearby, the fossilized remains of a small horned dinosaur called Protoceratops are everywhere. They are the most common clue in this ancient ecosystem. Then, a discovery is made that seems to tell a simple, dramatic story. A fossilized nest of elongated eggs is found, and lying directly over it, with its skull crushed, is the skeleton of a strange, bird-like theropod. Its beak is short and powerful, seemingly perfect for cracking things open. The conclusion seems obvious: an open and shut case. The team believes they have caught a thief in the act. This creature was raiding the Protoceratops nest, stealing its eggs, when it was caught and killed. Perhaps by a sudden sandstorm that buried them all, or by the furious returning parent. Back in New York, the renowned paleontologist Henry Fairfield Osborn examines the find. He needs a name for this new dinosaur, and based on the evidence, the choice is clear. He christens it Oviraptor Philoceratops. The name is a formal accusation. Oviraptor means egg thief, and Philoceratops means lover of ceratopsians. The name itself is a headline: egg-stealing dinosaur with a taste for Protoceratops. The story is just too good to question. It paints a vivid picture of a sneaky, villainous creature, a Cretaceous scoundrel. The name sticks, and for decades to come, this is how the world will know the Oviraptor. It is defined not by what it was, but by the crime it was accused of committing in its final moments. But as you will soon see, the stones of the Gobi Desert hold their secrets close, and the truth is often buried deeper than the bones. To solve this mystery, you have to look past the name and examine the suspect itself. Standing before you now is a living Oviraptor. It's not the giant, scaly monster of movie nightmares. Instead, you see a creature about 6 feet long, standing as tall as a person, with much of its height coming from its long, slender legs. Its entire body is covered in a coat of well-developed feathers, creating a shaggy, bird-like silhouette. These aren't the sleek, aerodynamic feathers of an eagle. They are more primitive, perhaps for insulation against the surprisingly cool desert nights, or for a dazzling display to a potential mate. At the end of its long tail, you can see a fan of broader feathers, a feature anchored by fused vertebrae called a pygostyle, exactly like the structure found in modern birds. It moves with a quick, nervous energy, a far cry from a lumbering reptile. Your gaze is drawn to its most distinctive feature, the head. It's short, deep, and surprisingly strange. Many of its close relatives sported a prominent crest on their snout, similar to that of a modern cassowary, likely a vibrant structure used for species recognition and signaling. But the real centerpiece is the mouth. It is a powerful, completely toothless beak. This was the supposed evidence of its criminal lifestyle, the perfect tool for cracking into eggshells. And it's true, the beak is immensely strong. A biological nutcracker capable of delivering a powerful, crushing bite. But as you watch it, you realize such a tool isn't a specialist's weapon. It could just as easily crush the hard shell of a mollusk dug from a riverbed, split open a tough prehistoric seed pod, or dispatch a small lizard. Inside its mouth is another enigma. Two small bony prongs projecting down from the roof of its palate, a feature whose exact purpose is still debated by scientists. Its arms are long and capable, ending in three-fingered hands, each tipped with a sharp, curved claw. They are nimble enough to manipulate objects, pull down branches, or steady a meal. This is not the body of a creature singularly designed for theft. It's the body of a highly successful generalist, an animal built to survive in a harsh environment by being adaptable. Every anatomical feature that was used to build the case against the egg thief could just as easily be evidence for a completely different way of life. The very tools of the alleged crime might just be the keys to proving its innocence. A body like this, so finely tuned, wasn't designed in a vacuum. It was sculpted over millions of years by a very specific and challenging world. To truly understand the Oviraptor, you have to walk the ground it walked. The timeline shifts back 75 million years to the Late Cretaceous period. You are standing in the place we now call the Gobi Desert, but the world you see is both alien and strangely familiar. This is not the lush, steaming jungle of popular imagination. Instead, you find yourself in a vast, semi-arid landscape. Immense fields of sand dunes, sculpted by a relentless wind, stretch to the horizon, their ancient sands glowing orange in the low sun. These are punctuated by dramatic rocky canyons and sandstone cliffs, the very formations that would one day be called the Flaming Cliffs. The air is dry, and the climate is seasonal. For much of the year, it is a harsh, water-starved environment. Life congregates around the ephemeral rivers and oases that swell during a brief, intense rainy season, and then shrink back, leaving behind a network of life-giving corridors in the desert. There is no grass beneath your feet. The ground is covered with hardy, low-lying shrubs, tough cycads, and gnarled, drought-resistant conifers. In the wetter areas, you might find pockets of ferns and ginkgo trees, their leaves rustling in the constant breeze. This is a world of earth tones, reds, oranges, browns, and the dusty green of resilient vegetation. You are not alone here. This desert is teeming with life. You see a small herd of protoceratops, stout, pig-sized dinosaurs with bony frills and parrot-like beaks, trudging across the dunes in search of vegetation. They are the most common large herbivore here, the primary food source for many predators. A low-slung armored Pinacosaurus, a type of ankylosaur, waddles past, its tail club held ready for defense. Skittering between the rocks are agile lizards and small furry mammals, doing their best to stay out of sight. And then, you see the danger. A pack of sleek feathered predators, no bigger than wolves, moves with intelligent coordination. You are watching velociraptors, and they are a constant threat to anything smaller than they are. This was the Oviraptor's world, a landscape of scarcity and opportunity, a place where survival depended on speed, intelligence, and the ability to find a meal where others couldn't. In a world defined by scarcity, you can't afford to be a picky eater. Survival demands adaptability. This brings you back to the central question of the Oviraptor's alleged crime. What was it really eating? The idea of a specialized egg eater, or ovivore, is appealingly simple, but nature rarely is. While an oviraptor certainly wouldn't have passed up a free meal if it stumbled upon an unprotected nest, just as a coyote or a crow wouldn't today, its anatomy seems poorly suited for such a specialized diet. That incredibly powerful beak, designed for crushing, seems like extreme overkill for a fragile eggshell. It would be like using a blacksmith's hammer to open a carton of eggs. It gets the job done, but the tool is clearly designed for a tougher challenge. The evidence used to convict the Oviraptor just doesn't quite add up when you look closer. The real clues come from more recent, spectacular fossil finds. You are now looking at the fossil of a close Oviraptor relative, frozen in time. Inside its fossilized gut contents, scientists found a stunning piece of evidence: the tiny, delicate skeleton of a small young dinosaur. This is the prehistoric equivalent of a smoking gun. It is direct proof that these animals were predators, hunting and eating small vertebrates. You can imagine the Oviraptor moving swiftly through the undergrowth, its keen eyes spotting a careless lizard or a small mammal, and snatching it up with a sudden snap of that powerful beak. Another compelling theory takes you to the edge of one of the Gobi's ancient oases. In the mud and sand, you find the fossilized remains of shellfish. Now, look again at the Oviraptor's beak. It is the perfect tool for dirophagy, the eating of hard-shelled organisms. You can almost see it wading in the shallows, probing the sediment with its beak, pulling up a prehistoric clam, and cracking it open with one decisive crunch. Those mysterious bony prongs in its mouth might have helped hold the slippery shell in place. But the evidence doesn't stop there. The discovery of gastroliths, or stomach stones, in some of its relatives suggests they were also eating tough plant material, using the stones in their gizzards to grind it down. The truth, it seems, is that Oviraptor was no specialist. It was a master generalist, a true omnivore. It was a hunter, a shellfish eater, and a plant eater. A creature that could survive because its menu was as diverse as the challenging world it inhabited. Its diverse diet makes it a successful survivor, but it doesn't explain that first, damning piece of evidence. Why was that Oviraptor from 1923 fossilized directly on top of a nest of eggs? If it wasn't eating them, what was it doing? The answer would take 70 years to uncover, and it would come from the same sun-scorched earth of the Gobi. This new evidence wouldn't just challenge the original story. It would completely shatter it, redeeming the Oviraptor and transforming our understanding of dinosaur behavior forever. In the 1990s, a new generation of paleontologists returned to the Flaming Cliffs. They found what the first expedition had found: more skeletons of Oviraptor relatives, like the closely related Citipodi, fossilized on nests. But this time, there were more of them. Too many for it to be a coincidence. You are looking at one of these fossils now, a specimen nicknamed Big Mama, and it is one of the most poignant and beautiful fossils ever discovered. You see the adult skeleton, perfectly preserved, lying in a lifelike posture. But it is not sprawled randomly. Its body is deliberately and carefully draped over a circular clutch of more than 20 large, elongated eggs. Its long, feathered arms are spread out to the sides, covering the eggs in a protective embrace, exactly how a modern bird uses its wings to shield its nest. Its legs are tucked in neatly beneath its body. You are not looking at the fossil of a predator. You are looking at the fossil of a parent. Imagine the scene as it happened. A massive sand dune, destabilized by wind or a tremor, collapses, sending a river of sand rushing down into the nesting colony. The parent Siddhipati had a choice: run and save itself, or stay and protect its future offspring. It chose to stay. It hunkered down, using its body as a living shield against the suffocating, abrasive sand until the very end. This was not a thief caught in the act. This was a parent making the ultimate sacrifice. And then came the final, irrefutable proof. Scientists finally had the technology to look inside the eggs from that original 1923 nest. Within one of them, they found the delicate fossilized bones of an embryo. It was not a protoceratops. It was a tiny, unhatched baby oviraptor. The egg thief had died protecting its very own children. This touching portrait of parental devotion gives you a glimpse into the oviraptor's family life. But this life was not lived in a peaceful sanctuary. It was lived out on the dangerous sands of the Cretaceous Gobi, a world where every day was a battle for survival. You now see the oviraptor not as a thief, but as an integral part of a complex ecosystem. As an omnivore, it occupied the vital middle ground. It was not an apex predator, but it was far from helpless. It was a crucial link in the food web, a creature that both hunted and was hunted. You see it now in its nesting colony. Like many modern ground nesting birds, oviraptors likely gathered in numbers for safety. The landscape is dotted with the distinct circular mounds of their nests, each tended to by a diligent parent. There's a constant low chatter, a series of bird-like calls and squawks as they communicate, ever vigilant. The greatest threat here is not a mystery. You see a flash of movement on a nearby ridge. A pack of velociraptors, sleek and intelligent, watches the colony with predatory patience. They are the apex hunters of this specific environment, and a nesting oviraptor, tied to its clutch, is a tempting target. You can imagine the tension. A lone oviraptor parent must always be on alert. While it can deliver a devastating bite with its powerful beak and slash with its hand claws, it is at a disadvantage against a coordinated pack. The velociraptors would test its defenses, looking for a moment of distraction to dart in and snatch an egg or even overwhelm the parent itself. This was the daily reality, a high-stakes evolutionary arms race played out on the nesting grounds. But predators were not the only danger. The very environment was a constant threat. As the fossils themselves have shown you, a sudden, violent sandstorm could descend with terrifying speed, burying everything in its path. A prolonged drought could dry up the oases, forcing the animals into desperate competition for dwindling resources. Life for an oviraptor was a precarious existence. It was a constant struggle to feed itself, protect its young, and outwit the dangers of its beautiful but brutal world, making its decision to stay and shield its nest all the more extraordinarily. Against all the dangers of its world, the oviraptor survived and even thrived. But its longest and most difficult battle would be fought 75 million years after its extinction. It was a battle for its reputation, waged not on the desert sands, but in the quiet halls of museums and the pages of scientific journals. You are standing once again in front of that original fossil from 1923. For most of a century, the label on its display told a simple story of a thief caught in the act. Millions of people, from school children to scholars, learned the name Oviraptor and associated it with villainy. Now, you see it for what it truly is, a monument to parental sacrifice. The story of Oviraptor's redemption is a perfect illustration of how science is supposed to work. It is a process of discovery and, most importantly, of self-correction. The initial hypothesis was a reasonable conclusion based on the limited evidence of the time. But science does not stop at the first conclusion. It keeps digging. As new evidence emerged, more brooding parents, a deeper understanding of bird-like behaviors, and the final, irrefutable proof of the embryo in the egg, the old hypothesis was tested and proven wrong. In its place, a new and far more profound truth was established. This wasn't a failure of science. It was its greatest strength, a willingness to let the evidence, not the story, have the final say. This new understanding has slowly begun to permeate our culture. The slinking reptilian egg stealer of old comic books and movies is gradually being replaced by the majestic, feathered parent you now see in modern documentaries. The scientific truth has finally started to overwrite the fictional crime. The legacy of Oviraptor is therefore twofold. It is a beautiful window into the complex social lives and nurturing instincts of dinosaurs, proving that the behaviors we see in modern birds have roots that go unbelievably deep into the Mesozoic past. And it is also a powerful lesson in humility, a reminder that the stories we tell about the past are only as good as our evidence, and that the truth, patiently waiting in the stone, is often a more wonderful and surprising story than we could ever have imagined. So, the Oviraptor's long journey from villain to hero finally comes to a close. Its very name, once an accusation, now stands as a testament to one of the most powerful forces in the natural world, the unwavering instinct to protect one's young. This creature's story is a beautiful thread in the immense tapestry of life, reminding us that the echoes of the Cretaceous are not entirely lost to time. The next time you see a bird fiercely defending its nest from danger, you are witnessing a behavior with an ancient and noble history. You are seeing the living legacy of animals like Oviraptor, a devoted parent whose story of sacrifice, misunderstood for so long, now enriches our understanding of the lost world it once called home, and connects it, unexpectedly, to our own.